in this very short tutorial, I'm going to explain how effect size impacts sample size. I have another tutorial explaining the basic idea about effect size, so I'm not going to discuss it further. I'll put the link down below and you can refer to that if you want to learn more about effect size. So in this tutorial, I just focus on the effect size impact sample size. Here we just use two types of statistic tests. One is about the mean comparison. So typically we use Cohen D to do mean comparison. So we are saying that if X is a categorical variable, and so for instance, you have two groups, you have calculated two means, N1 and M2, and then divided their standard deviation. Of course, in this case, since that there's a mean, so the dependent variable is numerical data, namely that the y is on a continuous scale. In contrast, if both x and y are numerical, then we can use a correlation as a way to calculate the effect size. And as you can see that the definition of small, medium, and large are different for the Cohen D and Pearson correlation R respectively. And you can actually convert one to another. For instance, you can convert the Pearson correlation R to the Cohen D or vice versa. The basic conclusion about effect size and sample size is that as the effect size increased, the required sample size decreased. We are assuming that the same statistical power and the alpha level. I have another tutorial about alpha and beta. I'm going to also put a link down below if you want to learn more. But this video, we are going to just focus on effect size and sample size. Okay, so now we come to RStudio. So this is the R model file I wrote. Basically, the PDF file you saw was based on or was from this R model file. So here, so we're going to use the library pwr to demonstrate. So basically, we use the function pwr.t.test. Basically, we're going to talk about t-test, namely that correspondingly Cohen D is the measure for the effect size. And the effect size here we specify as 0.5, and the M we specify as none. So remember that N is the number of observation or participants in each group, and two sample t-tests, namely we need to times 2. 2n is the sample size. And the power is 0.8 and the alpha level 0.05. And then we are two tail tests, so we can, and then we say the result as result 1, and then you can also plot it. So let's run it. I run it again earlier, so let me just run it again. It will show the result again exactly the same. So 2 power result 1 is that it shows the needed sample size 64. No, actually this is not sample size. I mean, it's a bit confusing. So this is not sample size. This is participants in each group or observation in each group. So it times 2 is 128. So here is 64 times 2 is 128. So this 128 is the sample size. So it actually add a note here from the program is the n is the number for each group, because I guess some other people also find it confusing, so that they feel like there's a need to add a note here. And if we increase the effect size from 0.5 to 0.8, so actually you can change a number here, but let me just write out here separately. And so exactly the same R code from here to here. The only difference is 0.5 to 0.8. So this is 0.8. So let's run, and all other things are the same. So let's run it again. And as you can see that now the needed sample size is 26, rolling up 26, namely 52. The total sample size is 52. And so basically, this figure basically is like the x-axis sample size, the y is the power, and also specify the effect size. So different effect size will lead to different shape of the line. And as you can see, these two lines are different. That's why I explained that the needed sample size are different. So as you can see that we increase the effect size from 0.5 to 0.8, then the needed sample size decrease from 128 to 52. So this is the t-test example. Yes, we can also talk about correlation. So correlation use the function slightly different. It's called PWR.test. And we also read this as num, so that's the number we would like to calculate. And the effect size 0.3, that's our effect size, the smaller effect size. We can run it. And as you can see there, again, this is a sample size and this is power, and this tell you the number of participants or the sample size you need. And this is 85. Okay, slightly different from the t-test. Here, the N85 is the same sample size. So N actually is the sample size. Compare the t-test here, N actually is the each group. So you need to times 2 to know the sample size. But here, the N is the sample size. So as you can see, there's what's a no here in t-test, but there's no such no in the correlation, for the correlation. So this is the sample size. And you will increase the effect size from 0.3 to, for instance, 0.5. Let's run it. And as you can see that now the sample size reduced to the 29. So it was 85, now it's 29. So again, as you can see that this shows that as we increase the effect size, the needed sample size decrease. So I think that's it. If you have any questions, feel free to comment down below, and do my best to answer the questions you might have. Thank you for watching.